Okay, moment of inertia of a uniform disk of mass m and radius r. So, as always, we're going to think about it as being a shape that is in the xy plane, except this time it is a solid shape. Here's z, here's x, here's y. We're going to take our dm shape to be a ring. All right. The reason we will use a ring is pretty straightforward. It is because we've already got the idea that a ring has this nice constant moment of inertia. It depends on the radius of the ring. So let's get our ring out here. Whoopsies. I do want it to vanish on white. It's not quite where I would like it. I'd probably get this faster if I just hand drew it. All right. Oops. Okay. So there is our radius r. And that is our dm. All right. So m over pi r squared would be our m over a. That will be equal to dm over dA. dA, well, that's a little bit trickier. We kind of talked about this before when we did the calculus worksheet, but you can think of this as 2 pi r by dr. So the area would be 2 pi r dr. Okay, that means dm will look like m over pi r squared 2 pi r dr. The r squared is a constant r squared. It is the large R. It is the full radius. The little r, it varies. It is a variable, so we will change its value. All right, final dm when we cancel stuff out is going to be the mass divided by r squared. We'll put the 2 out in front, r dr. All right, I is integral of r squared dm. In this case, we're lucky and every piece on the ring is already a distance r from the center. So it's just straight up r squared. All right, our dm, 2m over big R squared, r dr. Our limits, we go from the innermost point to the outermost point, full radius big R. The 2m over r squared can come out in front. 2m over big R squared, integral from 0 to big R of r cubed dr. And we get the moment of inertia is 2m over big R squared, big R to the 4th over 4 once we finish that integral. And we can cancel some stuff out. And we get mr squared over 2. That is the moment of inertia for a uniform disk. All right. Let's see. We're going to make use of this for a couple different things, or at least we're going to make use of the ring again in a Wesher example. And then we can make use of the disk by stacking disks. We can make a sphere. So look forward to those. All right. That's it for this one.